This is part of the Unit 1, Topic 3, Graphs of Rational Equations, Expressions, and Functions packet. This is page 20 in the packet, which may or not have been homework. It looks like it was homework for Thursday, October 7th. If you're watching this video, then you know Mrs. Stein is out for the next few days, and this video is to go over the homework so that you are prepared for your upcoming quiz or assessment. So the top of the page says, determine what type of discontinuity is present in each function. If they exist, state the vertical asymptote and the coordinates of the whole for each function. So we are not doing end behavior asymptotes here. For this one, we are looking for vertical asymptotes, and if we find a common factor after factoring in the numerator and denominator, then we are also looking for whole, point, or removable discontinuity. So for number 1, it looks like I can factor both the numerator and denominator, the top by, I'm just going to say split the middle, the bottom by greatest common factor, and you can see that there is a common factor between the numerator and denominator, x minus 2. But first we'll talk about the vertical asymptote. There is no vertical asymptote because there is no factor or variable in the denominator anymore. Once I cancel the common factor in the numerator and denominator, that canceled factor represents the whole. So I set x minus 2 equal to 0, and I get x equals 2 as the x value. And then to find the y value, I take the simplified version of the equation, which gets rid of plugging 2 into the denominator and making the denominator 0. So by plugging 2 into x minus 6 over 3, I get the y value to be negative 4 over 3. That is point discontinuity, and that's representing a whole. Number 2, factor the numerator and denominator by split the middle. I get 2 binomials, one of which is a common factor, numerator and denominator. And again, we'll talk about that whole or common factor in a minute. For this one, there is a factor left in the denominator. So that is a vertical asymptote, because if x equals negative 5, then I'm going to be dividing by 0, which is not allowed. So x equals negative 5 is our vertical asymptote, infinite discontinuity. For the common factor x plus 3 equal to 0, that means x equals negative 3 is the x value of the whole in the graph, plugging negative 3 again into the simplified form of the equation gives us a y value of negative 9 over 2. So we have point or removable discontinuity at the point negative 3, negative 9 over 2. The top of number 3, the numerator has to be factored by difference of squares. The denominator needs to be factored by split the middle. Common factor, numerator and denominator of x plus 1, meaning that there is a whole at x equals negative 1. The factor left over in the denominator is x plus 2. Set equal to 0 means the vertical asymptote is at x equals negative 2, infinite discontinuity. For the numerator, not for the numerator. For the whole, I take the common factor, set that equal to 0. X equals negative 1 is the x value of the whole or removable discontinuity. Negative 1 plugged into the simplified equation is what gets us the y value for the whole of -2. Number 4, both the numerator and denominator are factorable by greatest common factor. When I factor out a 12 out of the numerator and x out of the denominator, I'm left with x plus 2 as a common factor numerator and denominator. X is left in the denominator, so that makes it the vertical asymptote. So x equals 0 is a vertical asymptote, infinite discontinuity. X plus 2 is the common factor. X plus 2 set equal to 0 means the x value of the whole is x equals -2. -2 plugged in the equation is 12 divided by -2, making it -6 for the y value. The whole is at -2, -6. That's a point of discontinuity. Okay, and for the last two, number 5, the numerator is by greatest common factor. The denominator is difference of squares, factored this way. Common numerator and denominator factor of x minus 1. X plus 1 is left in the denominator. That is our set equal to 0 to make our vertical asymptote of x equals -1. The type of discontinuity is infinite. X minus 1 is the common factor. Set equal to 0 means the x value of the point of discontinuity is 1. 1 plugged into the reduced rational equation is 1 plugged into 3 over x plus 1, making it 3 over 2. The whole or point of discontinuity is 3 over 2. Number 6 is just a little bit tricky because you cannot factor the numerator. When it's x squared plus 1, that's not difference of squares. That's sum of squares, and that is not factorable. Since I can only factor the denominator, there are 2 vertical asymptotes, 2 places of infinite discontinuity. After I factor the denominator to x plus 1 and x plus 2, one vertical asymptote is at x equals -1. The other one is at x -2. Of course, vertical asymptotes are infinite discontinuity, and when I get over to the wholes, there is none because I cannot factor the numerator. So I hope this helps with your homework. There will be more videos for the lessons and homework for the next few days. See you soon.